7600 wave numbers. So we basically have painted all the information we have into this picture. Now what I am asking you, using this information, calculate D naught for the D state. And what is D naught mean? D naught is this for the D state. Just to make it clear, that's D naught double prime and that's D naught prime. So now it's only a question of mathematical juggling. This plus D naught, right? Nu 0 0 plus D naught prime equals what? This plus this is the same as this plus this. So it must be the same as D naught double prime plus the spin orbit difference between the two states. What is U 0 0? 15,000. This is what I want. What is D naught double prime? 12,000. And what is the spin orbit splitting going to be? 7,600. So all you have to do is to just solve this out and see what D naught prime is going to be. And that's now what you will get. And in fact, this is what is done in real life. If I know some states, I can always play this game of putting all this information that I have and getting information about the excited states. And in fact, sometimes you will even find, I will know this state very well. This has happened quite a bit of times. But I may not have a lot of information on this state. The ground state I might be struggling to get information. But somehow I have information on the excited state. But then what do? If I turn this problem around, say that I know this, can you find me this? Yeah, you can. Again, the same issue will come in. And it has happened in the case of iron, it has happened. That we know the excited state better, and using that excited state information and all the allied information, I actually come back and tell you what the ground state dissociation energy is. And then when thermodynamics people go back and do this experiment and find out what the dissociation energy is, it turns out to be quite good. And that's a number that I did not get by looking at the ground state spectroscopy. I actually got the information by deducing it from excited state spectroscopy. But the whole point is you can play this picture, paint this picture, and from this get information that you want, provided you have everything else that you need to know in this case. Very often you may not have just one unknown, you may have maybe two unknowns. Then what you really do is you start guessing one based on order of magnitude estimates. I know this cannot be more than 10,000 for some reason. And if it cannot be more than 10,000, then I know that this cannot be more than a certain value. At least I place an upper or a lower limit of that number. And this is how you sort of polishing the information that you have on given molecules. But where it is as clear as this, and these are again real numbers that I took, the ground state for the iron molecules actually is 12,400 some wave numbers. And that was known because of this little interplay between the information of the ground state and the information for the excited state. Okay, I think I'll stop here, and maybe tomorrow 7 o'clock we will meet and we will go through problem set 5 and try to finish problem set 6, and then if you want I will go back to the 1, 2, 3, 4 and we can do that also if you want. But as I said, the reason I am doing this first is because in the final exam you're going to get a whole lot of questions from the third part of the course. You will get some from the first 2 parts, but that's going to be relatively small. But for those of you who have not scored well in the first 2, you can't take a risk with missing out on the first 2. You have to do everything well so that you get a good score in the final exam that will make up for what has happened in the first 2 exams. So don't leave out anything in choice. I will just do the third part and not worry about the first 2. You probably may not have the gut really, so you have to get everything straight. So Wednesday and Thursday maybe I will do assignments corresponding to the first 2 exams, and we will go through that. Yeah.